This is intermediate algebra, September 21st. We're starting chapter 10. And the PowerPoint should look like that because there's something wrong otherwise. Here we go, make it bigger. Okay, you can see all the little things on top and on the side and everything. Okay. So, radicals, radical expressions, blah, blah. Okay. What is the square root of a number? If we have square root of 4, what is that? 2. How do you know it's 2? Like, what is your thinking? How do you know it's 2? Yeah, square root is the opposite of squaring. We're thinking which number multiplied by itself, in other words, gave you 4. Okay, so moving on. This is, some things might be easy. Okay, but we're recording, so okay, so now we want to move to the next slide. Okay, square root. Okay. What is square root of 0? Don't need to read it. What's square root of 0? Say something. It is 0. It is 0. Okay. So I'm going. As I said, the number 0 has just one square root, 0 itself. Square root of 0 is 0. Okay. The next thing. So now, come on. Oopsie. Okay. For example, to make this a little lower. Oh yeah. So every number you can have a positive and a negative number, right, as a result of the square root, because if you have 16, like square root of 16, this could have been made of minus 4 times minus 4 or 4 times 4, right? So because both of those make 16, so you don't know which one was it if it said square root of 16. So you always need to consider, yeah, so the square root could be positive or negative 4 if you like. Okay, the square root would be that, right? Okay.
So is that how we would answer it? Positive.
Well, this is in general. If it's so this is okay. So let's move on to the next. Hold on. Moving on to the next. This is the general case, but here we go. Okay, come on. Oh, we have to be together. Yeah, okay, so I'll explain what happens with the plus and minus. So for example, if it says find the 2 square roots of 49, you think, okay, which 2? If this says 2 square roots, one is what, 7 and the other is minus 7. Right. Because 49 can be made as minus 7 times 7 or 7 times 7. But this is if they say find the 2 square roots. There is something called the principal square root, which, so if you're looking for the principal square root, the main one, so the principal square root would be just 7 in that case. When you get the positive, if I ask you for a number, what is the square root of 121? You just need to say 11. You're not going to say minus 11 or negative 11. This is what we're looking for if you have a number. This is the principal square root. Okay. All right. But, so for example, let's practice here. So what is the principal square root of 81? Yeah, it says right there because I cannot hide it. I know, weird, this, I don't know what's going on.
I didn't look.
It's okay. Okay, so how do you do the next one? Let's see. So if you have a fraction, what you can do to simplify it, you see there is minus in front just for like making it more fun. You can split your fraction into like square root on top and square root in the denominator, right? And then since you know what those square roots are, now you can get the answer. Right. Let's see if you want steps. If you don't want steps, you just look, let's make it blue. Okay. If you don't want steps, look on top. Oh, square root of 16 is 4, right? And then here square root of 81 is 9. So you still have like a fraction. So on top would be 4, on the bottom would be 9. But you can do the steps and split them.
And then you always have the negative.
Yeah, the negative doesn't have anything to do with the square root. The negative is just in front, just some negative there. So just carry it along. Okay, this negative again has nothing to do with the square root, just some negative. Okay. I know you know how to use calculator, so we're skipping this vital step. But there are students who don't know how to do that. Just so if you know to calculate square root on the calculator, so you need to feel that you're in good shape. You know, something. Yeah, sometimes. Yeah. In this class, you got to use the calculator wherever you want.
That's true.
That's true. So if you have calculator, use it. But I'm fine with the multiply stuff. It's good. Okay, so this symbol is called a radical. So this is another way. That's what the whole chapter is called, a radical expressions. You know. Radical. I don't know how, you know, in real life, people who do crazy stuff are called radicals. So I don't know. They're like too crazy. If you have a radical view, means you're like out there.
Then they're like not normal. Like,
yeah, something to extreme. Right? This is a radical kind of thing. So I don't know how to relate this with mathematics. Why this is called a radical and the other thing is called a radical.
I think it's just because it's a weird expression, right?
Yeah, probably.
Not that radical people are weird. They're cool people, but
they're weird. Yeah, because that's why they go radical, because they're not don't fit in the norm. Okay. An expression. Okay, so the whole expression, if you have a radical in there, is called a radical expression, obviously. And so the thing under the radical, if you had here like 5, whatever, 5x, this is called, you know, the thing under, it's called the radicand. Whatever is under the radical is called the radicand. No, I'm just telling you. It's just, this is just your, for common, yeah, because intelligence, increasing your intelligence. I mean, you need to know, because when they give you a problem, they say, what's the radicand? You need to know what is it. So here, look, identify the radicand. And what it is, it's just this thing under. Like, this is the radicand. This is all we had to do. Whatever is under the square root, this is called the radicand. Okay, and again, this PowerPoint. Okay. So, well, I really want to hide this. So let me hide it. I'll hide it a certain way, which would be, so we hide all this. Look how we're going to hide it. Okay. So now, for this function, find the indicated function value. So what is f of 1? F of 1 is, oops.
So wouldn't it be 4 times 1 minus 1?
That's correct. So what's 10?
3.
Right, square root of 3. Agree? Okay. We don't want to know exactly. I mean, this is the exact, actually. The calculator is giving you some approximation. Oh, yeah. So far, it starts really nice, this chapter. And then it's like some monster. Seriously, it is like, you know, starts only like some play. No, and then all of a sudden it's like, I mean, I like it. I don't mind because I know how things work, but I don't think students really like it after that. Okay, so what's that?
So are we capable of doing the monster?
I hope so. And the monster is really easy, but you know how kids are afraid of the dark? It's irrational. It's so funny, but it's irrational thoughts which you're afraid of what's in the closet. Because probably there's nothing in the closet. I know what they're thinking. And the same thing, those rational expressions create irrational fear by, you see why. It's not fear, but some kind of confusion. Okay, so what is f of 6?
I got 23.
23, okay. Square root of 23? What is f of 0?
So would that be 0?
Wow, so this is not a real number. Because you cannot have you know, what is the definition of square root? You multiply the thing by itself, you know, get what is the number, but you cannot multiply negative number times a negative number and get a negative number. It's going to, so this is not a real number. And where are we learning this? I think at the end of this chapter. Let me see. And where are the imaginary numbers? And let's see. Yeah, at the end of this chapter in 10.8, we're going to do imaginary numbers. You see how we call this. Okay, but for now, it's just not real. Yes, it's not real, and that's it. Okay. Not real. Okay. Not a real number. Okay, does not exist for now. Okay, so the next thing, don't worry about it. I did not put this on Alex. This is how the function looks. If you want to graph it, this is the general shape, but I'm not going to ask you to graph again. Just you can see how it looks. Okay. Okay. So this is a little details here. Saying, you know, that the answer is not just positive, you know, right? If you don't know, if it's not a number, like in this case, it's 8. The principal square root is 8, but they're showing you that it could be a negative if you don't know what the number is. So let's go next page. Okay. So here, if you want to simplify a radical when you don't know what the number is, it's a variable. So square root of a squared is going to be plus or minus a. All right. It depends. If a is greater than 0 is 8, but if a is less than 0, because you need to get a positive, you need to put a negative in front of the a, right? So if a equals negative 3, right, you're going to get negative of negative 3, right, which would make it a positive to get the principal square root. So just remember, there is always plus and minus. If it's a letter, if it's a variable, it's always plus and minus in front wherever we get the square root. Is it? Okay. Okay. So, or you can say this in other words, you can put absolute value around it. It's another way to say it. Because, right, absolute value was, if you want absolute value of negative 3, this is going to be negative 3, right? If it's a negative. Because it's 3. The absolute value of negative 3 is 3. So the absolute value does. I'm waiting for you to write it down. Okay, you know what to write down. Okay. So what do we need to do? Oh, simplify. Okay, well, let's, you don't see the bottom anyways. Okay, simplify. So we need to simplify these expressions. And because, okay, so what we need to do, because there is a letter here, we don't know what this expression is. We have to leave it in absolute value because it says squared right here, right? So technically, this is the solution if you have like 2 squared, right? Square root of 2 squared equals 2, right? The square, you know, tells you which number is multiplied by itself, right? And it's 2, but because of the letter, you need to put it in absolute values because you don't know what it is. You want, you know, we won't need to do much of this general, so this is just the theory. Usually what you have is a problem which you need to do something, so you won't have to do the absolute values. Okay, but this is if they ask you to do it, you do it. The next one, okay. Yeah, you see right here, right here.
Okay.
Right here. Yeah. So the next one, we have 12. So what we can do with this, we're like, we don't know what it is, so we should probably think, well, let's just write it as, well, what the thing is, do you know what square root? We didn't learn how to do this, huh? Do you know what square root of something to the power of 12? It is 6, but we did not. It comes from the next chapter. How do you know it's the power of 6? How do you do it this case? You're already there. You start. Oh, it's in the next chapter. Okay, let's just a short. Okay, we're going to go into details in the next chapter, but just how do you know is that? You can make this into. Okay, let's make it here. This is let's make it blue. So this is an extra, just to explain. Okay, you have opportunities to practice this a lot. So you have like 1, 2, 3, 4, 5, 6, 7. Oh my gosh, I need to write 12 of those. 8, 9, 10, 11, 12. And okay, so one way to think about it is if you have square root of x squared, right? This equals x, right? You know, plus minus, but equals x. So what happens when you have this is square root, this is 2? Technically, you can think that a group of 2 things comes out, right? This is one way to think about it. So from here, you have one group of 2 comes out as an m. Let's see, another group of 2 comes out as an m. So because it's 12, you're going to get 6 groups to come out, right? Because 12 divided by 2 is 6. Groups of 2 come out. So you end up with 1, 2, 3, 4, 5, 6 of those, which is m to the power of 6. Okay. So the reason they're doing it here is about the absolute value is the problem. Because they're like, do we need to put the absolute value? Do we have to put the absolute value like that? Or actually like that? The question is, do you need it or not? Okay, so do you need the absolute value? Why? No, it was the right guess. There is.
Wouldn't it be just like, for example, if you had the square root of 12, it would be. Oh,
No, it's
never
not.
mind. Never mind.
No, but it's still okay. No, so what it is, because this is an even exponent, that's what we're getting here. See, this 6 is even number. So anything to even power will be always positive. So then in this case, we don't need the absolute value because this is always going to be positive. This expression. But again, this is far-fetched. There's so many. Maybe this is the problem comes from the fact that there is so many ways you can do this m to the power of 12. There is another way with exponents, another. So there's so many ways to understand it. So I don't know which way works for you. So I need to find one.
I think that makes sense.
Okay, so again, here we're just after the absolute value. We don't even, so don't worry about how we got it. So the next one, another way, okay, I'll explain the other way using the next problem. So this one, you can actually make it into squared to the power of 5. No, but you need to do 5 here. Hold on, I need to do 5. I'll do 5 times 2, right? See, this is the same thing as x to the 10th, because you can multiply the exponent. The reason I did the 2 outside is because I want to cancel the, the 2's. Kind, And what I'm going to be left is x to the power of 5. But now, do I need absolute value or not?
Yes.
Why?
Because it's not anymore.
That's right. Look, Mariana, you're so progressive here. Because it's an.
Happened that one day. How did this off?
Oh, I don't know. It was long ago, but okay. This is an odd number, so if it's a negative, it's going to still be negative. Okay.
Wait. So how did you get rid of the 2's?
Oh, so let me explain. So let me explain. We can do the groups. Okay. But let me show the other way, because actually the groups is too long of a way. Let's erase. Another way to think of absolute of square roots, unfortunately, is as a fraction. So the radical here, radical 2 of something is equivalent to the same thing to the power of 1/2. I know. Radicals are actually rational exponents. This is what they are. I know. This is, I think, is the best way to explain, because once you get this is the definition. You know,
Okay.
the rational exponents are radicals. So this is the same thing written two different ways. So imagine you have here x to the 10th. See right here we have x to the 10th. So when you put the 10th right here a little higher, right? So when you have this, what do you do with the exponents when you have parentheses like that? That's right here with purple. So if you have x to the power of a b, what does this equal to? Okay, so the purple, how do you? Yeah, you multiply the exponents, right? So this is the property of exponents. Mariana multiplied. So let's erase it. Okay, so go back here. We have 10 times 1/2, right? So this was green, red, whatever. I don't know what I'm doing anymore. It's green. So when you multiply them, it's going to be x to the 10th times like 1/2. And if you put a 1 under the 10, if you would like to, if you like symmetry, you can put 1. So then what would happen? You simplify. So this becomes 5, right? So it becomes x to the power of 5.
Okay.
So another way to think it, this looks complicated. Just let's go back to our problem right here, right? The way I think, you know, this is 2. Cut the exponent in half, divided by 2 is 10 over 2. It's going to be right.
When you get 2.
It's radical. It's not written. This is one of those rules. If the, you know how 1 is a ninja, the ninja 1, you can write now. So the rules are that if you have square root, you know, square means 4, but I don't know, somehow got into there, you know. Because it's not quadratic, I don't know. Square, what is square? I don't know, square. I don't actually know what you mean. Quattro means 4. So maybe square means, I mean, it's a side by side. So maybe it means 2. We need to, let's see. Yeah, let's go Latin. Let's see what the heck this square means. Hold on. Where the word square comes from. Oh, here. Where the word where the root, I wanted the root of from Latin, quadra. What does quadra mean? Yeah, quadra means 4. Hold on, Middle English shortening. What this is 4. It doesn't say, but this is what it means. And it has 4 sides, so I'm going to where did the term square root come from? How about that? Dates and deviates from the old French. Okay, a square. Oh, from some French, not from Latin anymore. It was used in something honest or fair. So it's come from a square. The word square. Wait. Where does the, let's see. Where does the square root? Okay, that does the word square root? Yeah, we don't know. But this is, I mean, math in real life, the things that are kind of interconnected. Okay. Square root existed in technicians angle. Here's an explanation. The length of each of the 2 sides of a square contains any corner. It was a square root. Ah, okay. So anyway, square, okay, square. It's 2. When where we're getting into that, they don't write it. If it's 2, they don't write it. You understand it. Like, you know, logarithm on the calculator, logarithm, if you look there, it just says logarithm, but the base is actually 10 on the calculator. But you don't write it. If it's 10, you don't write the base. Or there is logarithm called LN, and the base for this is E, but you don't write it. You just use that. So it's kind of convention, whatever. So, Mariana, if you don't see anything, it's 2. Right. If it's 3, they will write it. If it's 4, they will write it. But if it's 2, they don't write it.
Okay.
Because it's called
So
square root.
nothing in front there.
It's 2. Yeah.
Automatically.
Yeah, it's 2. This is the one with 2. Okay. So we should not assume that people know that. Okay. So let's erase all this. Again, so cutting it in 2 because this was 2. This is the same thing again as exponent of 1/2. We actually dipped a little bit into the next chapter, which is good. Okay. Blah, blah, and blah. Okay. Here we go. Cube root. Now, if it's cube root, you write it's a cube root. And the cube root does not need absolute value because if it's negative, it's negative. If it's positive, it's positive. A number 3 times by itself would be a negative. It's a negative. So don't worry about the negative. So cube root of 27 is 3. Because 3 times 3 times 3 is 27. In your calculator, now we're going to, okay, we'll do the calculator probably for this, for practice. Okay. Next one. Okay. Okay, well, let's hide it. How are we going to hide this? Hiding it. I don't think we don't need to hide it. Okay, let's just look here. So cube root of negative 27 x cubed. So what you need to do here, I'm writing it right here. The negative is not worrying me. Oh, here it's right here. You can actually split it. Okay. Let's just split it into cube roots. Makes it easier. Okay. Cube root of negative 27 and cube root of x cubed. Right. Cube. Don't forget now the cube thing. It's the 3 is there. I think it's called an index. They didn't say what it's called, but it's the index of the root on the radical. So what's cube root of negative 27? Which number multiplied by itself 3 times give you negative 27? Negative 3. Okay, this is the first one. Then, you know, this is 3 and this is 3. So the cube root technically falls out. Divide the 3 by 3, you get x. All right. You see here the cube. Okay, let me write it separately. If we have, let's do green. If we have cube root of x cubed, this is the same thing as x cubed to the power of 1 over 3. Right? Because a radical is a rational exponent with this thing in the denominator. This is the definition. We're going to learn it next chapter. I'm just saying. Got it? Okay.
Well, like you said,
Just think,
we're dipping our feet
we're
into
dipping
the
out. Okay, we're dipping our feet. So if it's 3 and 3, they just kind of cancel. You know, if it's 4 and 4, if they're the same, you know, the index on the radical and the exponent, they kind of cancel. Groups of the same number come out. Okay. The next thing, blah. Which number multiplied by itself is 0.8? Well, do we have calculator? You can use use your phone. To make it scientific, because you need to have the. It's okay. We're better than students who use Siri to tell them what things are. So, calculator is better.
I don't like it.
I don't, but my son got the little Google dots, you know, Google thingy, and what's called Alexa. No, what the heck is it called? No, oh, it's Google. It's called Google. Yeah. So I say, Google, do this and do that, and it does.
Your son does that?
I do it.
Oh.
Because I took it. I said, you don't need it. It was free. Okay. So this is the calculator and find cube root of 0.008. So on different calculators look different. Mine is like x to the power of y. Did you find it, Mariana? What is it?
Is it 0.430?
No, it should get that 0.2.
Oh.
So type 0.008 and then press the button which looks like Jason, you found it? It looks, okay. Did you find 2? Yep. Okay, it's inverse. Sometimes it's on top of the, you know how they have inverse and we got it. Okay. Oh, let me do the next one. So this one here, let's do it green. So what you can do, oh, what you can do is still a fraction, all right? So you can split it if you want. So what's cube root of 27? Which number multiplied by itself 3 times give you 27? 3. Which number multiplied by itself 3 times give you 64? Now you're like, I'm puzzled. 4? That's right. But if you don't know this, you can do 8 times 8, right? Yeah, you can do, this is 2 times 4 and 2 times 4. And then this is 2 and 2 and 2 and 2. So you have a lot of 2s. 1, 2, 3, 4, 5, 6. Okay, we're getting overboard. Okay, 4. This is for the next chapter. Ta-da! Let's move next. Okay. If you have a fourth root, it's the same thing. If it's an even number, don't need absolute value, right? Here, the number n, you know, when it's this thing is called in n, the mentioning it, it's called an index. Index, right? So whatever it is, if this is cube root, the index is 3 of the radical, right? This is called index right there. See this little thing? Called index. If it's 5, the index is 5. The name is index.
That's just what it's called.
Yeah. So they're saying for any root, doesn't matter, you know, if it's a not. When this is k and this is k, just the number comes out without absolute value. Because again, this is the same thing as a to the power of k, the whole thing to the power of 1 over k, right? And when you multiply them is k times 1 over k, and if you put your 1 here, the k's cancel, and you just got an a, right? So whenever the index is the same and the exponent is the same inside, cancels the radical. Beautiful. And well, use your calculator. What is, I'm trying to hide it, but I cannot. What is 5th root of 243? What is it? What is it? 3? Is it 3 k's and 3 times? It is 3, okay. How about B? What is, you can say what it is without doing anything now. That's right. How about C? You don't need it. How about C? It is same, right? Because this equals this, so it just comes out.
Oh, cool.
Yeah. This actually concludes chapter 10.1. So the things to remember in this chapter are the part about the absolute value. Right? This is the part to remember. So Alex might give you, did Alex give you a case and did you see any of those about the absolute value? No? I think I tried to remove them, but I'm not completely sure. So let's do a few, we're going to do a few problems here. Okay, so we're going to treat this by making it all black. Stuff here like, got a big screen, okay. I'm just going to get something from the book, which says, find, okay, so it says find, what are you finding? I'll do this too, okay. Square root of 81 y squared. And the trick here is in the y squared part. Do you need absolute value or not, right? So what you can do, you can split them. So what would be this with absolute value things if you need to guess, and what is it? Yeah, but then y needs to be an absolute value like that because of the square. And again, you want to do this later on. This is just in here. They want to teach you this.
Wait,
Right.
so you put it in between the absolute value thingy?
Because it's an even. Here it is even 2 and 2. And you want to get the principal one, which is positive. So if y was negative by any chance, you need to make sure y is positive. Because you can get minus y squared right here and it to look exactly the same, right? Right. Yeah. And this is the, so we just tried for a few minutes. We just move on to the next, which I explained already. Okay. So I'm moving on a little bit to chapter 10.2. How are we going to do that? We are going to, I guess let's open chapter 5.2. This, yeah. Oh, no, 5. 10.2. Hold on. How do I say 5? Oh. Ah. Oh. Save the changes. Sharing screen has stopped. Okay, good. Oh, I guess I close the whole window. Okay, well. What are we doing? Going to Populi, which is right here. And we are going to chapter 10. You see next chapter. Oops. I know how I did it. I was doing it here. Oh, but then I cannot hide the thing still. But it's okay. We can do it here. I can write. No, I was writing before too, but it was kind of small. Now it's easier. But I cannot hide them. But see, I hide them. Okay. So here, the first wisdom is right here. Oh, they squished it right there. So this is the first thing. That first, they're giving you the. This is what I told you. Oh wait, where is the writing thing? Oh, do you see it? How do you see me? Okay. See it? Oh, you see it because this is a shared screen. Okay, people were not seeing it if they were on Zoom. Okay, now they see it. Oh man, I hope they were seeing it before. I think so. Okay, I hope it's not going to be an empty screen. I hope it wasn't. Okay. Okay. Oh yeah, so this is what I told you, which was, let's get the annotate. That nth root of something is equivalent to a to the power of 1 over n. This is what the nth root is. It's just 1 over n. You know, it's n is the denominator of a fraction. This all there it is. This is need to, Marianne, need to remember this. You need to dream about it. You can dream whatever.
How is this going to help me in life?
Well, you can, let's see. It should help in life. Depending what you're going to do in life. What are you going to do? Do you know what you're doing? You see, you don't know. So how do you know it's not going to help you? So at this point, we don't know what you're going to do. So that's why we want to make sure you know everything.
Oh.
But it also develops your abstract thinking. You know, if you want to be in any engineering or any like business or anything like that, you need to use this because there are formulas, you know, related. But even if you never do anything connected with mathematics, you still your brain would be capable of like assimilating abstract concepts. You like your brain has so much abilities. I forgot how many cases. Do you know by any chance what percent of our brain we are using?
Like 0.6.
Let's see.
Because when I started going back to school,
Uh-huh.
I feel like I can remember things more. Like when it's like, oh wait, now we gotta remember this.
Yeah, percent of the brain. I don't want that. 75% of the brain is water, though. What percent?
Oh,
What? Ah. The brain. I want this one. Well, this is what the Americans believed. But this is just a myth, according to interview. No, no, this is this is what Americans believe. It might be a myth. Because actually, it's so there's so many things we believe we don't question. I was thinking, like when I was trying to motivate students to do maths maybe 10 years ago, I don't know, when the beginning of the college, I was like saying, hey, the brain is like it's a muscle, and I believe it's a muscle. I never thought about it because I have heard people say, oh, the brain is a muscle, we need to exercise it, but it's not a muscle. Okay, it's a myth.
Your expression is the brain is like a muscle.
It could be, but it's not. What means to be like a muscle is not the muscle, not even like a muscle. What percent? Well, so they're saying that usually you use different parts of the brain for different things. But anyway, actually there's so many connections, there's so many neurons and combinations in your brain that it's infinite possibility of what you can do. All right. So definitely you have the brain power is there. All right. Okay. So moving on. Okay, so this is what it is. You're developing your abstract thinking right now, which God's giving you. Because many people, they think, oh, I'll never go to math, and then, oh, I want to do this. But hey, if you decided not to do math, that you cannot do this. Like let's say they get their associate of arts degree somehow, and they forget about it. And 20 years later, they want to go and do some kind of business, and then all of a sudden they need to relearn the math again, right? If they didn't. So you better do now everything you need to do. Okay. Okay, so here you go. This is what you practice. It says, so I'm going to hide the bottom part so we can have like plenty of space to write. Here we go. Oh, left a little white corner. Let's cover it. Okay, so I covered the problems. Okay, let's go back. Let's undo. Okay, let's cover only the solutions now. Right here, covering only the solutions. Okay, so they say, what did it say? It says rewrite it. No, write it again. Is what it says. Rewrite. Right. See what it says? Without the rational exponent. What do they mean? What they wanted to do? Okay. So this is a rational exponent. So it's a lot of language. That's why I'm starting the next chapter a little bit, because there are a lot of vocabulary. You need to know what they want you to do. If you don't know, be like, what do you mean by rewrite the rational expression without exponent? It's like, what do you mean? Okay, so here. So rewrite without rational exponents. What are rational exponents? This is a rational exponent. See, a ratio. See ratio? Ratio? They don't want those. So how can we do? Okay. So I'm going to erase, undo, 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 and undo. So the first one. So m equals, doesn't equal, m to the power of 1/3. But there is nothing you can simplify. So if you write it as a radical, see right here, there is no rational expression, there's no ratio anymore. So this is what they wanted in the first one. They don't want the rational expression, just write it as a radical, and here you go. Okay, they wanted to get rid of the ratio here, rational, okay. Or rational exponents. Okay. Say, next one, B. Actually, I can erase this. No, cannot erase. Okay. B, let's do different color, like blue. So for B, now we can write it on there. Okay. We have this thing. So what you can do actually, honestly, there is very simple way to do it, but then you're not done. You need to do the whole thing. So let's do it two ways. Okay, let's do this two ways. One way. Let's present 9 as 3 squares. 3 squared, right? It's 1/2. So now let's distribute the exponents to each one. Let's make yellow and distribute, right? This 1/2 needs to multiply by this and by this. So what you're going to get is, So it's going to be 3 squared times 1 over 2, right? And I can put the 1 under here. Times x to the 8 times 1 over 2. And I can put the 1 under, right? So what would this be? The 2 would cancel in the first one. So it just be 3. And on the second one, 8 over 2 is 4. So it's going to be x to the 4. This is one way to do it. All right. Okay, let's do the next one. The next way, I'll put it right away over here. I see scratches on my screen. This pen somehow scratched the screen. Well, okay. So the next one would be, let's write it as radical. You know, the 1/2, you can just do it immediately like that. And honestly, if you just want to do what they say rewrite without rational exponents, you already done right there, right? But then they say simplify. So it's that, I need to simplify. It's not done. So what we can do,
Easy though.
okay.
I see what is going. I see what's going on there.
Where? The second one?
Well, yeah, you just do the what is it called? The little house thingy of 9 and then of 8.
You mean radical, right? Yeah. So the first one, this is going to be 3. But what would be the square root of 8 to the 8? Oh, what is going to be x to the 8? That's right. Hey, so here you go. This is another way. Real one. Yeah. Okay. So let's do the third one. Man. I need to, because if I erase, I will erase my whole black screen. So I want to erase my black screen. So we're going to squish it here with yellow. Okay, on the side. This one. Oh man. Okay, so what we need to do, actually look at it, the x, nothing would cancel, right? There is nothing to cancel the 5, so just all we do is x, y squared, z, and we're done really. But don't forget the 5 right there. It looks nice. Got it. Okay. And finish here, let me erase. Ta-da! So we stop right here. So what you need to do, to something. No, it's okay. So it's a lot. We covered a lot today. So go work on Alex, and we'll continue on Thursday. Again, be ready. Those might be unpleasant at some point, but if you learn the rules at the beginning, if you're just very familiar with the 1/3 thing, then it's okay. You got it.
My head doesn't hurt.
Oh, good. So let's stop recording, I guess. How do we stop recording? Okay, so everybody, see you Wednesday.